angle of friction. Consider a block of mass m, okay, which is placed on a rough inclined surface. The weight of the block acts downward, that is mg, okay, and normal force acts upward, that is n. For suppose here we applied an external force F towards right side. If block is not moving means that indicates there will be a frictional force which acts opposite to the applied force along the surface of contact. Okay, that friction is called static friction. Then at particular value of applied force, if block is begins to move means that friction is called limiting friction. The resultant of that limiting friction and normal reaction makes an angle theta with the normal. That angle is called angle of friction here. Okay, how can I calculate that angle? For that I will construct one triangle. I will join this Rn, okay, then from this triangle Rn means that is opposite to friction, so it will be F, okay, and here On means normal force, that is N. So from this triangle, from this right angle triangle, in right angle triangle ORN, tan theta is equal to Rn by On, that is Rn means F by On means N. So we got tan theta is equal to F by N, okay. Here F means mu N, where mu means coefficient of static friction, okay. So Nn cancelled, then we got tan theta is equal to mu. From this we can calculate angle of friction, that is theta is equal to tan inverse mu. So here we calculated angle of friction, that is theta is equal to tan inverse mu. So what is angle of friction, my dear? Angle of friction means the angle between resultant of friction and normal force with normal force is called angle of friction, that is theta is equal to tan inverse mu. Now we will calculate angle of repose. Angle of repose, okay. I will represent angle of repose with alpha, okay. Consider a rough inclined plane which makes an angle alpha with the horizontal, okay. Then here I will place one block of mass m on this inclined plane. Okay. So here angle of repose means the angle made by the inclined plane with the horizontal surface at which block begins to slides down. That angle is called angle of repose. So here we have to calculate this angle of repose. Okay, that I will consider what are the forces acting on this block which is having mass m. Okay, so here the weight of the block acts vertically downward. Okay, that is mg. Then this weight mg makes an angle alpha with this x-axis, that means with this reference line. Here we can resolve this mg into components along horizontal direction. Its component is mg cos alpha, and vertical direction, that is mg sin alpha, mg sin alpha. Okay, and here this mg cos alpha will be balanced by reaction force. Okay, that is n. Opposite to mg sin alpha, there will be a frictional force, that is F, which acts opposite to the direction of mg sin alpha along the surface of contact, that is F. At equilibrium, we can say that mg sin alpha equal to friction and mg cos alpha equal to reaction force. So this is equation 1 and this is equation 2. Now divide 1 by 2, then you will get sin alpha by cos alpha is equal to F by n. From this I can write tan alpha is equal to F by n. Okay, so here F means we know that mu into n by n. So here n cancelled, then we got tan alpha is equal to mu. From that we can find angle of repose alpha equal to tan inverse mu, my dear. So we got angle of repose, that is alpha is equal to tan inverse mu. But in previous slide we got angle of friction theta also tan inverse mu, and here we got alpha equal to tan inverse mu. So from this we can say this angle of repose will be equal to angle of friction. So we can say alpha equal to theta. Now we will calculate acceleration on rough inclined surface. Acceleration on rough inclined plane. So here case 1, beta greater than alpha. So here beta means angle made by the rough inclined plane with the horizontal. Okay. Beta greater than alpha means block will slides down with an acceleration A. So we have to calculate this acceleration here. For that, I have to identify what are the forces acting on this block. Its weight is acting downward, that is mg. Mg makes an angle beta with the x-axis. Then its horizontal component will be mg cos beta. Okay. And its vertical component mg sin beta. So here mg cos beta balanced by normal force n. Okay. Then here when block is sliding down with force mg sin beta means opposite to this force there will be a frictional force which acts opposite to the direction of mg sin beta along the surface of contact, that is F. We have to calculate this acceleration. Okay. So what is the net force here? Here net force along x-axis, that is mg sin beta minus F is equal to ma. Mg sin beta minus, in the place of F I can write mu n, where mu means coefficient of friction, that equal to ma mg sin beta minus mu. In the place of n is balanced by mg cos beta, so I can write mg cos beta is equal to ma. Okay. Now I can cancel m on both sides. Then I will get acceleration A is equal to g sin beta minus mu g cos beta. Okay. If I write g commonly outside, then I will get g of sin beta minus mu cos beta. So we got acceleration on a rough inclined plane when beta is greater than alpha. That means angle made by the rough plane with the horizontal is greater than angle of repose. We calculated acceleration, that is g of sin beta minus mu cos beta. Here we can say that this acceleration is less than acceleration due to gravity. Now case 2. What is case 2? In case 2, if angle made by the inclined plane less than angle of repose means block won't slides down. In such case, what is the minimum force and what will be the acceleration? That is case 2. Case 2. What is case 2? In this case 2, beta less than angle of repose. When beta less than alpha, block won't slides down. Okay. This is block. So here beta less than angle of repose, so block won't slides down. In this case, at minimum force, what will be the acceleration? So here first we will identify what are the forces acting on this block. weight acts downward, that is mg. Okay, so this mg makes beta with x-axis. Okay, then its horizontal component will be mg cos beta and vertical component will be mg sin beta, and here mg cos beta is balanced by reaction force, that is n. If beta less than alpha, this block won't slides down. So we have to calculate acceleration at minimum force. Upward direction, if we apply some minimum force, then there will be frictional force which acts opposite to the direction of applied force along the surface of contact, that is F. Okay, so here acceleration will be in the direction of applied force. Okay, so the minimum force to push the block upward direction, that will be F is equal to mg sin beta plus friction. So that is equal to mg sin beta. In the place of friction I can write mu n, that is equal to mg sin beta plus mu n, means n is balanced by mg cos beta. Okay, so here if I write mg outside, then I got inside bracket sin beta plus mu into cos beta. So this is the minimum force that should be applied to push the block in upward direction when beta less than alpha, that means beta less than angle of repose. So in this case acceleration will be a equal to f by m, that is mg of sin beta plus mu cos beta by m. So here m cancelled, then we got acceleration, that is a is equal to g bracket of sin beta plus mu cos beta. Okay, so this is the acceleration for minimum force when beta less than angle of repose.